Question 25, got a nice big tree diagram to go for, haven't we? Well, we've got different suppliers. So we've got supplier X, supplier Y, and supplier Z. And they're either good or spoilt. They're good or they're spoilt. They're good or they're spoilt. So look at that. And let's put some probabilities on this. Supplier X has 20% of them, so I'll put a 0.2 there. And 3% of these oranges spoilt. So if 3% of those are spoilt, that means 97% of those ones are all okay. Let's go then. Y has got 40%. So Y is 40% there. Clearly that means there's going to be 40% down there as well. And it's found that 4% of their oranges are spoiled. So, oops, wrong one. 0.04 there, and 0.96 of them are good. The remaining oranges are supplied by supplier Z. So that's why I put a 0.4 down there. And clearly some of those will be good, and some of those will be spoiled. Overall, 5% are spoiled. So, how do you get spoilt ones? The spoilt ones come from X. So these are the X spoilt ones. Or they come from Y. These are the Y spoilt ones. Or they come from Z. And these are the Z spoilt ones. Let's just work those things out then. So I've got 0.5, that's 0.0, careful with the extra 0 there, 0.006, 0.016, and 0.4x here. And so x here is equal to 0.07. 7%. 7% of supplier Zs are spoiled. Part B. Show that the event orange is from supplier X and orange is spoilt on arrival are not statistically independent. So if they're independent, then X, sorry, I'll not use X because there's already X in there. If they're independent, then the probability of A and B is equal to the probability of A times the probability of B if they're independent. So we need to figure out these two, see if they're equal to each other. So oranges from supplier X. Oranges from supplier X we know was 0.2. And orange is spoilt on arrival. That's what we've just had here. Orange is spoilt on arrival is equal to 0.05. And if we times those two things together, then we get 0.01. But we've already been told what the probability of X and spoilt, well, that's these ones here, isn't it? It's these ones here, is 0.2 times 0.03 is 0.006. So these two things are different, therefore they are not independent. Getting a bit of a scribble down there. But you've got the idea there, haven't we? This is the rule we're using, and there's just the working for it.